It is another beautiful day in the digital classroom. Always a beautiful day in the digital classroom, unless you don't have internet. Welcome, everybody. We are doing some interview practice. My name is Rafiq, and we're going to do some interview practice where we think aloud, look at a problem, and try to see how we would approach this problem in an actual interview situation. Okay, so getting started, we're looking at Leetcode problem 912, sort an array. Reading through the description and assuming that we just read through it, we're thinking about asking clarifying questions. Okay. So number one, we want to repeat this back or re-say this back to the interviewer, and make sure that we understand what we're being asked. So I would say something like, okay, so you're expecting me to sort an array of numbers, and it needs to be in log in time, and it needs to not use any of the built-in functions of the language, um, and with the small space complexity possible. Okay. And making sure that I understand that from the interviewer, I would go and proceed to validate the inputs and the outputs. So like here, when we're talking about when it says something like nums, I'm thinking, okay, what kind of nums are we going to have within this array? Is it just numbers? What kind of numbers? Do we have floating numbers? We have, what are we looking at? Negatives, positives. So here we have positive numbers. Here we have duplicates, which is also makes a difference as well. And then here are like the constraints. So we have length up to 10 to the 4. So that will require something better than n squared time. And then we have, like we already said, negative numbers. We have positive numbers, including 0. Okay. So after we finish, clarifying with the interviewer those things, we're going to do a quick brainstorm. So we start kind of thinking about like all the different ways that we can sort. Sorting is something that you have to study sorting, and there's a lot of different ways. So we'll start with the ways that we usually don't sort, bubble sort. Then we also have selection sort as well. We also have insertion sort. And then to the more used ones, merge sort, and then bucket sort. And so merge sort would be the one that I will go through with this one. And I'm just kind of thinking that, kind of forgetting, but remember merge sort is being a stable sorting algo. So that's also a benefit. And talking about complexities of these, so I wouldn't use bubble sort because I would talk about how that one is n squared. And then you have the same thing for the next couple ones, selection sort as well, insertion sort as well, and merge sort. This would be in log n. And bucket sort is actually a really good one because in best case scenario, it's a log n, but in worst case scenario, it could be in log n. So depending on the inputs that you have for bucket sort. I would still go with merge sort because it is in log n, and it is one of the more, like I said, it's a stable logarithm, and it's one that is often is used. Like we have Tim sort, I think, which was developed by, I forgot, Google, like I forget. Anyways, so this is a recursive divide and conquer algorithm, merge sort. Basically, we are if you want to like break it down, one way to break it down to think about this recursive function is that you are a manager and you're going to divide your input array. You're going to be given an input array. You're going to divide it into two, and you're going to give it to your two subordinates, and you're telling them, hey, look, go sort this, and give it to me when it's sorted. They're going to go sort it. They're going to give it to you, and so you're going to have these two sorted input arrays, and then you're going to sort it, and then you're going to give it to your manager, right? And so that's the way this function works. It calls on itself. And so with recursion, we always start with our base case. And here, we got to define the length of we're going to need the length of this. And then, like I said, the base case, we have two possible cases with this situation. So we're going to, divide our array that we're given in half. So when it gets down to 2, it'll be, 1, or it could be possibility that one subordinate can get a 1 and they're dividing into 2 and it'll be 0 and a 1. So those are our 2 base cases. So if n equals 1, we'll just return those nums. And if n is less than 1 or 0, then we will return an empty array so that we don't have any mistakes. And then after that, we get to the recursive case of our recursive function. And for this time, I'm just going to call the function itself. You could have a helper function within this main function, sort array function. You could have a helper function within it and have that call itself. But this time I'll just, call the main function. And like I said, we're calling our subordinates. We're going to give to our subordinates to take whatever we have as a middle manager, and we're going to split that and give it to our 2 subordinates. And so I'm going to call one, whatever I'm getting back from one of the subordinates, I'm going to call it left sorted. And then again, like I said, we're going to call our function on ourself, and we're going to pass into it, like I said, half of whatever we're given. So we're given nums, so we're going to split that in half. And in Python, a quick way to do that is they have the notation where they can use a colon like this. So this is basically saying I'm slicing that original nums array from index 2 to index 6. And so for here, we're going to start from the beginning. So we're not going to indicate the first parameter, and we're going to go all the way until halfway of that parameter of the given input. And then we're going to do the same thing for the right side. So right sorted, and we're going to call the same array, and we're going to, like I said, take the second half. So we're going to start from the midpoint and go all the way to the end. And so when I leave that last parameter blank in Python, that means that it's going to just cut off that last half of that array. And then so now we got to imagine that we were just giving back these 2 sorted arrays from our subordinates, and so we're going to kind of lace those together. And different situations that this could be. It could be maybe the left sorted is all smaller than the right sorted, and we just put them together like that. It could be the opposite, or it could be some combination of between. So we're going to first define some variables, because we're going to be iterating through here. And so while I, and this would be for our left sorted, is less than the length of left sorted, and j is less than the length of right sorted. Well, this is less than that. We will we're going to check to see whatever the current so this is kind of like a 2-pointer almost situation here. So we have our 2 pointers pointing to the leftmost elements of both those arrays that we were given, and whatever one is smallest, we're going to put that into our temporary array, which I forgot to put here. So we'll have a temporary array, and then so yeah, so we will, as we check, so if left sorted of I is less than right sorted of j, then temp dot append left I, and then we're going to increment that I pointer. Again, it's kind of like a 2-pointer situation. And then the other situation is that it's not smaller. And then we're going to append right sorted. And then we'll increment that j pointer, and that will keep on going all the way until it gets to the end of one of those, whichever one of those arrays goes to the end first. And then we have what we call the gather phase. The gather phase is where we, just collect the rest of the, whatever is left over from whatever array hasn't been used yet. So again, so like if I, for example, was a shorter one, and we go through and we break out of this while loop, because all the elements in the left sorted is done. So then we got to gather the rest of the right sorted and put it into our temp so that we can return that. So the way we just do this, we just set it up for both, because both situations, it could be that I is still has some elements left. And so in that situation, we would just, so while I is less than that, we'll do temp dot append left sorted of I, and just keep on incrementing I and finish that. And maybe there is a situation where J is still, there's still J elements, or the right sorted. And so we'll just keep on gathering those elements. And we are about done. J, and we'll increment J. And then after all that, our temp array will be in sorted, because our subordinates did most of the work, and we are just enjoying the fruits of their labor, and we just put those last few things together, and then we return it. So it's also good to kind of walk through your code before you submit it. Some interviews, they don't have a working editor IDE, so you have to like walk through it and just make sure that you catch all your spelling mistakes, maybe some logic mistakes, make sure everything is clean and correct. But I do have a use of an editor here, so I will go ahead and just run that and just see how it goes. Let's see how that does. Out of range, right sorted, less than length of right sorted of J. Sorted. Oh, this is definitely error here. Would that solve it though? No. Because this is just one element, but I don't want to take the length of one element. I want to take the length of the whole array. So yes, that would definitely cause some issues. It looks like it's passing. Let's go ahead and run it. And so then we have to, if this is correct, we got to talk about the space and time complexity of this. And so time complexity, this is an n log n. Let me be more clear. So this is big O of t time equals that, and space complexity. So we weren't the most space efficient here, since we're using that temporary array. So this would be that temporary array we O of n, and then on our call stack implicitly we would do the height of the tree, which would be a log n, but it would so since it's addition, we just go to the largest one, which would be O of n. So then it would be kind of a question to the interviewer: do we want to optimize this even more, or do we want to leave it at that? Like we said, the bucket sort would be able to make this faster. It would be able to go over n time. But hopefully this would suffice. And that's it. So hopefully this is helpful. Let's if there's any mistakes within my analysis here, please leave a comment and I will try to learn from that. Thanks for watching. Hope it was helpful, and adios.